Hello Nitin, we are live now. You can start.
Okay, so good afternoon, everyone. Welcome to this live interactive session for this course. I'm Nitin Pranami, one of the TA for this course, and Professor Gandhi will join us shortly. We haven't received any queries from your side in the Google form, but I request that you put your queries in the YouTube chat box so that we can answer your queries. Otherwise, we won't be able to continue the session. So please put your queries in the chat box and we'll answer your queries. So far, we haven't received any queries. Chat box and also in response sheet. So shall we wait for 5 more minutes because there are no queries here? So I see that there are 4 members watching the stream. So if you have any queries, any questions, please ask in the chat box so that we can answer your queries. The session is mainly to answer your doubts, your queries. Because if you won't have any queries and doubts, then there's no point of having interactive session. So you ask your questions and we answer your questions.
Nobody has joined till.
Again, I'll ask students that if you have any queries, any doubts, please ask in the chat box so that we can answer your queries and doubts.
Nitinji, I think there is no one here.
No, there won't be any one here on the Zoom link. They
Okay.
are on the YouTube, watching on YouTube. So they will put their queries in YouTube chat box.
Okay.
So there are five right now students who are watching, but so far no one has given any query. So we can't continue without queries. So shall we continue with this session or stop here because no one has asked any question?
Hello, Nitin. If there are no one, you can stop the session. Hello, Nitin. Should we stop the streaming? I think he's busy in call with sir because I am dialing him and his phone is not reachable. Okay, okay.
Okay. So once again, welcome to all those students who are watching. Okay. Actually, we wanted that if you have any queries, then you ask those queries in the chat box, and they will answer those queries. But there are no queries, so I talked with Professor Gandhi, and then we will talk about some electronic system which I am working on. So I'm Nitin Pranami. I'm doing PhD under Professor Gandhi, and I am also one of the TA for this course. Okay. So I'll talk about leech robot, which I'm working on for my PhD project, which is my PhD topic. So, leech is an organism, so it has a specific kind of movement, it moves. So, we are making a robot which copies this movement. Actually, this movement that our robot makes is more related to gymnast, the way gymnast flips. So, this robot is also going to flip and move. Okay, so it's a mechatronic system. It will have mechanical components and as well as electronic components as well. Okay, so I'm going to talk about this system. And in the meantime, if you have any queries related to this course, then you can write these queries in the chat box. Okay, and then we'll answer your queries. So first we need, like, we want to move, to make our robot move. We need some actuator. So here we have used actuator, and then we also need a controller. Okay, so and to control it, we also need some microcontroller. Okay, so we have used in this leech robot, we are using XL430 robotics motors, okay, which has inbuilt controller with it, and we use microcontroller to control it. Okay, so it has inbuilt PD PID controller. We can tune its gain, and then we can, you know tune our motor also. So we are using microcontroller OpenRB150 to connect to this motor. So there will be two hubs, and there will be a flexible link which will be connected to these two motors. Okay. So if if you have done assignment number 3, then there's a problem which is asked there. Okay, that we have a flexible link and a mass attached to it. So it's a that kind of system. Okay. There the beam is horizontal, but in our case, in this leech type of robot, the one hub will be stationary on the ground, and another hub will be the tip mass, and the flexible beam connecting these two masses is our flexible link, flexible beam. So it's a complicated system, though it appears to be simple. The reason is because of flexibility. If you have a rigid link, then we only have, in such a system, we will only have 1 degree of freedom system. But as we have flexible links, so it is unlimited number of degrees of freedom are there. Okay, very high degrees of freedom. Okay, infinite theoretically. So to design controller for such a system is a big challenge. Okay, so this is the challenge we are going to handle. But before that, first we have to make a mechanical model, mathematical model for such a system, which can predict, okay, uh, the movements or its state variables of the system. Okay. So if you'll see that in assignment number 3 also, we have considered this aspect of modeling, okay, mathematical modeling, and there we have considered Euler beam theory. So same theory we are going to use here to model the system. Okay. So when we are making this mathematical models, we also want to validate this model through experiment. Now there is what we are working here right now is that when we are making mathematical model of this system, so there is one interesting thing here also, that is that this system has tip mass and a beam. So under certain circumstances, the system will become a chaotic system. So through our modeling, we also want to you know study this system, that when, under which conditions or which frequency, because we are going to, what we are going to do is that we are going to give oscillatory motion to the base. Okay, and then we want to see the response of the tip mass. connected to this flexible beam. Now, under conditions, certain amplitude or certain base frequency, this system will behave like a chaotic system. What is chaotic system? Chaotic system is a system in which you won't be able to predict the output after a certain period of time. Mathematically, it is possible, but practically, what happens is because of small changes or some inaccuracy in your initial conditions, the actual response will completely diverge from what you're expecting. In chaotic system, even if there is small change in your initial conditions, then after a certain period of time, you'll see that your system will have completely different response for these two different initial conditions, which are, you know, different by very small amount. There is very small change in it. Okay, that's why it is very difficult to predict, because whenever we give any initial conditions, initial inputs, so we can measure it up to certain accuracy level. Beyond that, I mean, we can't. So even that small change which we can't measure, that will have a different response. So that's why we can't completely predict. Even though mathematically we have a model for such system, we can predict it, but because of sensitivity to initial conditions, we cannot practically predict it beyond a certain time period. Okay, because after that certain time period, it will completely deviate from the predicted trajectory or output. So this is what I am doing right now in my PhD project. First is to validate my mechanical system, make a mathematical model, and then validate it, so as it is also going to be a chaotic system. So we want to study that. Okay, so for that, what I have done is to note down the tip displacement. We are using strain gauges. Okay, so this is what I'm showing you, the practical application of what you're going to study in this course. In assignment 2 or assignment 1, you have studied about strain gauges. Okay, so that is a sensor. So in our system, what we are using, that at the base we are attached four sensors. Okay, sorry, four sensors which are our strain gauges, two on one side and two on the other side. So when this beam is bending, so one side will be under contraction and one side will be under tension. Okay, so in beam bending theory, that there's a neutral axis, and on one side of neutral axis there is tension. Your beam is under tension, and on the other side it is in under compression. So two strain gauges are attached to the side which will be under compression when it is bent on one side, and other two side will be under tension. So using Wheatstone bridge, we'll measure what is the change. So as you have seen in that assignment, we have asked few questions. There's one question which is related to it, that okay, what is the advantage of half bridge, quarter bridge, full bridge? So one of the advantage here, when I'm using this four strain gauges, two on the compression side and two on the tension side, that as I have used four, so if there is any change in resistance due to temperature, it will be cancelled out. Okay, if you remember the formula there, that the change, what we get is delta R by R. So there are four resistances. So for each resistance, we'll have delta R by R. Okay, so this delta R will have change in resistance due to tension or compression, and also if there is some change due to temperature, that will also be there. But if you see the formula for this, bending, the way we have attached, okay, then you'll see that 2 delta R by R for two resistance will be positive, and for 2 it will be negative. Okay, the way we have connected, so for compression it will be negative, so already it will have negative sign, minus delta R by R. So there there will be change in the resistance will also be negative, so it will become positive. So overall sensitivity will increase by 4 times here, okay, because all the components will add. And because of temperature, if there is any change, okay, so that will be cancelled out, because that will always be positive. If temperature increases, then resistance, okay, that will also increase there. Okay, so it will, if it decreases, it will decrease, so it will happen, it will be same in all the resistances, all the 4 strain gauges, so it will cancel out. Okay, so that is one of the advantage if you know this question which we have asked in the assignment. So that's how we can use this theory which I am using here in my project. Okay, so that way you can also use it. Okay, I'll also ask that if you have any questions, any doubts. Actually, I'm sharing my experience with you because you haven't asked any questions, okay, here in the chat box. So I request that if you have any doubts, any questions related to whatever we have covered so far in this course, then you can ask in the YouTube chat box, and then we'll answer your queries. I see that there are 4 or 5 students who are watching online. So anyway, no one has asked any questions, so I'll continue. So the strain gauges I have connected. So using that, I measure what is the strain at the bottom of the beam, and then using that, okay, that strain what we have measured there. Using that, actually what we get is we get voltage. Okay, so we have connected this 4 strain gauges to the output of this 4 strain gauges to amplifier, and from that amplifier I have a D space controller. So I've connected to D space and I measure that voltage there. And then if you see, if you have studied the assignment 2, then we have some formulas which relates the change in resistance, okay, to this voltage that we are measuring, and then use an strain gauge factor. Using all that, we get a relationship, and from that we can find out the voltage that we are measuring and gauge factor. With that, we can find out what is the strain there, and once we know the strain, then we can find out what is the there's correlation between the strain that we are measuring at the bottom and then at the tip. So there are some papers in that, which is already one of the paper which is published by Professor Gandhi. Okay, so in that correlations are mentioned. There are some formulas, so I won't go into that. So within that correlation, we find out what is the tip displacement, and then once we know the tip displacement, and then we also find out what is the tip velocity. So using that, we get portrait, face portrait. So face portrait and point carrier map are some tools which we can use to find out if our system is actually chaotic. So if in a point carrier map, if we get points only at in that plot, if we get points nearby one region, then we know that this is a linear. This is a periodic system. If we get around 2 points, then it is biperiodic. Okay, but when this plot is actually scattered all over, okay, then we can say that okay, this is a chaotic system. It can be a chaotic system, and the factor that we have to see is that Lyapunov exponent. Okay, so after that we can, at least we can say that this system can be, but at least when we have this biperiodic or periodic, then we know that it is not chaotic, because we don't get scattered plot, your point carrier map. Okay, so once we get that, okay, then we can find out that whether the Lyapunov exponent is also positive there, because if that is there, then we can ascertain that okay, this is a chaotic system. So here, as we study in our mechatronic system, so I'm using this sensors and microcontrollers, then we have motor, so this is all system, and then we have this mechanical beam, okay, this mechanical component, okay, this mass. So I have to consider this Euler beam theory, and then using the sensors I have to measure this, and so we are doing all this, we are plotting it live. Okay, so we are taking this data, and then I have made some codes, okay, which find out using this stain data, it can find out what is the tip velocity and tip displacement. Okay. So still I don't see any question here. So anyway, I think there is no question here. Now he's here, so I think we'll stop here. Thank you very much, everyone, for joining. Thank you.